I wanted to talk a little bit about the addition rule. In probability, the addition rule says that if two events are mutually exclusive, meaning only one of them can happen at a time, then the probability of event A or event B happening can be found by adding the probabilities of the two separate events. Before we move on, I wanted to explain a little bit more about what mutually exclusive means. If two events are mutually exclusive, it means that either one event or the other happens, and they can't happen at the same time. For example, heads and tails are mutually exclusive because each time you flip a coin, you either get heads or tails. You either get one or the other, and you can't get them both at the same time. Also, if you draw a card from the deck, red and black are mutually exclusive because each time you draw a card from the deck, you either get red or black. You either get one or the other, and you can't get both colors at the same time. So here's the addition rule down here in symbols. It says that if events A and B are mutually exclusive, then the probability of event A or event B happening, one or the other, is equal to the total of the probability of event A and the probability of event B. Here's an extension of the addition rule. It says that if events A, B, and C are all mutually exclusive, meaning only one of them can happen at a time, then the probability of event A, event B, or event C happening can be found by adding the probabilities of all three events. So if all three of these events are mutually exclusive, and only one of them can happen at a time, then the probability of A, B, or C happening is equal to the total of the probability of A, the probability of B, and the probability of C. Now that we've gone over the addition rule for both two events and for three events, let's go through some examples of using the addition rule. First, let's use the addition rule to find the probability of getting a head or a tail when a coin is flipped. We said that if you flip a coin, heads and tails are mutually exclusive events because when you flip a coin, you either get a head or a tail. You either get one or the other, and you can't get both a head and a tail. So since these two events are mutually exclusive, we can use the addition rule to get the answer. So we know that the probability of a head is 1/2, and we already know that the probability of a tail is 1/2 because 1 out of 2 sides have a head and 1 out of 2 sides have a tail. That means that the probability of getting a head or a tail when a coin is flipped is equal to the total of these two probabilities. So we just have to add 1/2 plus 1/2 to get the answer. Since the two fractions both have the same denominator, since they both have 2 on the bottom, we can just add the two numerators to get our answer. So 1 plus 1 equals 2. 1 plus 1 equals this 2 right here on top. And then we just keep the 2 on the bottom. And then the answer is 2 over 2. And if you divide 2 by 2, you get 1. So the answer is 1. So the probability of getting a head or a tail when a coin is flipped is 1. And what this is actually saying is that this event right here, which is head or tail, always happens. Remember, an event with a probability of 1 always happens. That makes sense because when you flip a coin, you always get a head or a tail. Nothing else can happen. Each outcome has to be a head or a tail. So since head or tail always happens, then it means that head or tail has a probability of 1. Now let's go over another example. In this example, a card is drawn from a deck, and we want to know the probability of drawing a diamond or a heart. And these two events are mutually exclusive because when you draw a card from a deck, you can get a diamond or you can get a heart, but you can't get both of them together. You can't draw a card that's both a diamond and a heart. So since these two events are mutually exclusive, we can use the addition rule to find the probability of getting a diamond or a heart. To use the addition rule, we just have to add the probabilities of the two separate events. And the probability of a diamond is 13 over 52, because in a deck of cards, 13 out of 52 cards are diamonds. The probability of a heart is 13 over 52, because 13 out of 52 cards are hearts. And we can add these two fractions by just adding the two numerators, because if they both have the same denominator of 52, which means we can just add these two numerators of 13. So 13 plus 13 is 26, and we just put the 26 over 52. And then if we could also divide 26 by 52, or I'm sorry, we could reduce the fraction to 1/2. And then after we reduce the fraction to 1/2, we could divide 1 by 2 and get a decimal answer of 0.5. So when you draw a card from a shuffle deck, the probability of a diamond or a heart is 0.5, meaning there's a 0.5 chance of this or this happening, one or the other. Now let's go over another example. In this example, we'll use the addition rule for the probability of 3 events. We'll use the addition rule to find the probability of getting a 1, a 2, or a 3 when a piece of dice is rolled. And the addition rule can be used here because these 3 events are mutually exclusive. When you roll a piece of dice, you can get a 1, you can get a 2, or you could get a 3 possibly, but you can't get any of these events together. None of these events can happen at the same time. So this is our addition rule. When you roll a piece of dice, the probability of 1, 2, or 3 happening is equal to the total of the probability of a 1, the probability of a 2, and the probability of a 3. We already found out earlier that each of these probabilities is 1/6, because every side has a probability of 1/6. So 1 out of 6 sides have a 1, so the probability of a 1 is 1/6. 1 out of 6 sides are a 2, so the probability of a 2 is 1/6. And 1 out of 6 sides are a 3, so the probability of a 3 is 1/6. So to get our answer, we just have to add these 3 fractions. Like I said earlier, if the fractions all have the same denominator, meaning they all have the same number on the bottom of the fraction, you just add the 3 numerators and then put the answer above the denominator. So 1 plus 1 plus 1 equals 3, and we just put the 3 over our denominator of 6, and the answer is 3/6. Or if we reduce, the answer is 1/2. Finally, we could change our answer to a decimal by dividing 1 by 2, and the answer is 0.5 as a decimal. I wanted to go through just a few more examples. Here's an example that says when you roll a piece of dice, what's the probability of rolling a 4 or higher? And if rolling a 4 or higher means what's the probability of rolling a 4, a 5, or a 6? Because those are the 3 numbers that are considered 4 or higher. So if I wanted to, I could have written this out as what's the probability of rolling a 4, 5, or a 6? It would mean the same thing. So the probability of rolling a 4 or higher is, like I said, the same thing as the probability of rolling a 4, a 5, or a 6. So to get the answer, you just add the probabilities of the 3 events. Each event has a probability of 1/6, so we just have to add these 3 probabilities. And just like before, they add up to 3/6, which reduces to 1/2, and 1 divided by 2 is 0.5. This one says, what's the probability of rolling a 2 or lower? And this is really just asking, what's the probability of rolling a 1 or a 2? Because 1 and 2 are the two outcomes that are 2 or lower. So the probability of rolling a 2 or lower, or the probability of rolling a 1 or 2, is equal to the total of the two separate probabilities. And we already know that each side has a probability of 1 over 6. So the probability of rolling a 1 is 1 over 6. And the probability of rolling a 2 is also 1 over 6. So the probability of rolling a 1 or a 2 is equal to the total of these two probabilities. 1 plus 1 is 2. So the answer is 2 over 6, which reduces to 1/3. And we could also divide the 1 by the 3 to get a decimal, and our answer would be 0.33. That was the last example that I wanted to cover for probability.